Good morning, grade 9. Our lesson today is chapter 10, lesson 6, geometric probability. We started the first part of the lesson yesterday, and we're going to continue our lesson today, the second part. So let's review what we have learned yesterday. If I want to know the probability of finding any point on BC, of a line here, of a part of a line here, this part is called BC. So first of all, I will write the measure of BC up in the numerator. What I'm going to write down, I'm going to write the measure of the whole. The whole is AD. So up, I'm going to write the part that is mentioned, which is BC, and down I'm going to write the whole, which is AD. But what if I'm talking about an angle? So if I'm going to ask about a point that is in an angle here. So if any point is here, so I'm going to write the measure of the angle up in the numerator, and I'm going to write the whole angle down in the denominator, the whole angle down in the denominator, and the whole angle, as we know, it is 360. But let's talk about the area. If I want to know the probability of finding a point in the shaded triangle, the probability of finding a point in the shaded triangle. So first I have to get the area of the shaded triangle first. Then I'm going to write it in the numerator. Then I'm going to get the area of the rectangle, and I'm going to write it in the denominator. Okay, go to the next page, please. Okay. As we learned yesterday also, a point is chosen randomly on AD. Find the probability of each event. The point is on AD or CD, or if I found or means and, I'm going to add. Okay, and we also solved the spinner. It is about angles. When I am talking about angles in a circle, so the total measure of all the angles is 360. Let's watch this video.
Spinners are great because they remind me of playing games, and I love games. So you spin a spinner and you see where it lands. And here I have a spinner where I could see the angle made by the various colored sectors. So 120 degrees, 55 degrees, 60 degrees, 25 degrees. This one's actually mysterious purple. And we can actually use those degrees to figure out a variety of probabilities. Let's find the probability that the pointer lands on yellow. Well, I see that out of 360 equally likely, assuming the spinner's fair, equally likely places that the spinner can land, 120 of those degrees are yellow. So the probability of yellow, wow, I should really be using a yellow marker, shouldn't I? Sorry. Probability of yellow equals, well, 120 out of the 360 equally likely possibilities, which is 1/3. And that kind of looks like a third of a pie, doesn't it? So that means that if we do this again and again and again, we would guess that about a third of the time we would be in yellow. Not in yellow. Not in yellow. Yellow. Cool. All right. It won't always happen, by the way, not yellow, not yellow, yellow, but over time we'd expect to see that on average. So that was just a fantastically lucky, wonderful circumstance where I look good. And that happens so infrequently that I like to grab them. All right, let's now find the probability that the pointer lands on blue or green. Blue or green, those are two mutually exclusive events, which means that they have no overlap. You either are in blue or you're in green. There's no way to be sort of in both, and whatever that is, fuchsia or whatever the color means. So actually, to find the probability of one or the other, we actually just add the probabilities together. So we find the probability of each and then add. So the probability of blue or green equals the probability of blue plus the probability of green. And that's because these events are independent. They're mutually exclusive. So the probability of blue is, well, 55 out of 360, plus the probability of being in green, which is 25 over 360, because that's 25 is the angle formed there. And so when we add these up, what do we see? We see 80 over 360, which if we simplify, we get 2/9. So 2/9, not very high probability, but there again, it corresponds to the fact that these aren't very large sectors, so we wouldn't expect that we get in there. Oh, look, I got in there. That's pretty good. I just got into the green, but I don't think I'll do that again. Oh my gosh, I got into the blue. This is like my lucky day. But now I'm in purple. Anyway, it's not very likely if we keep doing it. I just happen to be fabulously lucky. All right, I should go to a carnival and have someone guess my weight. All right, let's find one last probability. Let's find that the probability that the pointer is not landing on purple. Well, the way to do this is to actually realize that we could look at the opposite question, because the probability of not purple equals 1 minus the probability of purple. So that would equal 1 minus, and what's the probability of being on purple? Well, we can figure out what that angle is. We know the entire thing is 360, and we can actually add up 120, 55, 60, 25, and we'd see 260, and we know the whole thing is 360, and so we see this angle is 100. So we see 100 over 360.
So as we know, girls, here we have two choices. If they want not purple, we have two choices, whether to, one, to subtract the probability of purple from 1, or to add all other colors over 360.
And if we get a common denominator, this is 360 over 360 minus 100 over 360 is 260 over 360, which simplifies to 13 over 18. 13 over 18 is actually kind of close to 1, which means that the probability of not landing on purple is somewhat high. So if I spin this, I'd expect to be more likely that I'm one of these other places than on purple. Let's see how lucky I can be. Not on purple. And there you go.
Okay, girls, now we're going to use area to find geometric probability. Find the probability that a point chosen randomly inside the rectangle is in each given shape, round to the nearest 100. So I want to find the probability of a point that will be in any of those shapes. I have 3 shapes in the whole rectangle. 3 shapes are inside the whole rectangle. So the whole rectangle, the whole shape that has the 3 shapes is the rectangle. Imagine yourself, you are in the class, you are Ayla, you are Tala, and you are Yara. Yara is apart from the whole class. Tala is apart from the whole class. Ayla is apart from the whole class. The whole class here is the rectangle. The whole here is the rectangle. So I have to calculate the area of the whole rectangle here, which is 45. The formula of the area of the rectangle is what? B multiply H. B is the base, which is 45, multiply the height, which is 20. So the probability of a point that will be inside the equilateral triangle here. So the area of the triangle is A half multiply A B. So the height is 6, the base is 36 root 3. So when I multiply it, it will be 187 meters squared. And don't forget to square the unit because we are calculating the area. Then the area of the rectangle. The rectangle is the whole. A equals B multiply H. B is the whole, is the base. H is the height. So when I multiply both together, they will be 900. So the probability of finding any point inside the triangle is 187, which is the area of the triangle over the area of the whole rectangle, which is 900. I want to find the probability of a point that will be chosen randomly in the trapezoid. So first of all, I will find the area of the trapezoid. The trapezoid is found inside the rectangle. The trapezoid is found inside the rectangle. So inside rectangle, so the rectangle is the whole. So first I will get the area of the trapezoid. The formula of the area of the trapezoid is area equal half multiplied by base 1 plus base 2 multiplied by half. So a half multiplied by 3 plus 12 multiplied by 10 equals 75 meters squared. And don't forget to square your unit because we are calculating the area. Then since we are finding the probability of a point inside the trapezoid, so I'm going to put the trapezoid in the numerator, and down I'm going to put the whole, which is the rectangle. Next, I want to find the circle. The circle, what is the formula of the circle? Pi r squared. The radius is 6. So pi 6 squared is 36 pi, and the value of pi is 3.14. So 3.14 multiplied by 36 is 113.1 meters squared. So now I got the probability of finding a point randomly on a circle inside the rectangle. Okay, girls, now we have the page of the exercises, page 721. If we look to exercise 4, find the probability that a point chosen randomly inside the rectangle is in each shape. Round to the nearest 100. As we see that we have 3 shapes. I have triangle, its sides are known in front of me, given in front of me. The height is 10 and the base is 10. So I will get the area of this triangle and I will put it in the numerator, and in the denominator I will put the area of the whole rectangle. The whole rectangle is what? 24 multiplied by 48. Then the trapezoid. The trapezoid is here, all its sides are given. Then the square here, all its sides are given also. The square has all its sides are equal in length. Part of the rectangle that doesn't include the square, the triangle, the trapezoid. What I'm going to do here? I'm going to get the area of the triangle and get the area of the square and get the area of the trapezoid and subtract the 3 areas from the area of the whole rectangle, and I will get their difference. I will put this difference over the whole rectangle. Okay, girls? I hope you're going to continue this page, and don't forget to answer your homework. See you tomorrow. Thank you and bye-bye.